Hello, my name is Coach Fulton. I am your Algebra 2 teacher and your Bridge Algebra 2 teacher. Beginning of the year, I'd really like to do some review on solving linear equations. Linear equations are equations that make lines in math. Anything that looks like this on a graph. You can see that. Those are 4 different types of lines. There's infinite number of directions they can go, but these are some common looking ones that you might see, which are represented by variables. And variables, if you remember, are unknown numbers represented by letters. So sometimes you can see what letter X as a variable or letter Y as a variable. So those are 2 common letters that you'll see in math when solving linear equations. So what I'd like to do is kind of go over some basic review of algebra. We've got a summer off, so before we start jumping into more advanced things, let's kind of review some basic ideas of math and algebra. Solving an equation like 2x equals 210. You know, I know those lights are really glossy on this board. It says 2x equals 10. Let me make it a little bigger on this so you can see it on the video better. I'm sure that's really big now. 2x equals to 10. If we divide by 2, 2x means, multiplication. 2 times a variable x equals to 10. You can do that probably in your head, but we do the inverse operation when we cross an equal sign. So we're going to divide by 2, and then we know 2 divided by 2 is 1. They simplify. 1 times the variable x is x, and then we have 10 divided by 2 is 5. So that was a very basic example of an equation, a simple equation, single variable. Single variable just means one x or one y in it. Let's try another one. 2x plus 7 equals 15. If you remember, in math, we could have like terms. I know that's kind of hard to see because of the gloss of the reflection of those lights above me. But that reads 2x plus 7 equals 15. So we're going to combine like terms. Remember what like terms are. We've got a 2x right here. We have a plus 7. These are called terms, right? They're separated by plus, minus, and equal signs. So we have a 2x, we have a plus 7, and then we have a 15. What are the like terms? What looks alike, right? The 7 plus 7 here and the 15 are like terms. So my mind goes, which way do I go? Do I bring the 15 over this side or do I bring the 7 over this side? Well, my variable is the key. There's a 2x here. The x will stay on the left side of the equation because that's where it's located. Now, I'm going to move the plus 7 over to the 15 over the other side of the equal side to get it away from the 2x. I've got to get the x by itself at the end. That's the goal. So plus, if you remember all the operations for the inverses, plus becomes a minus, minus becomes a plus, multiply becomes a divide, and divide becomes a multiply. These are all of our inverse operations that we use in math. So anytime you cross the equal sign, we know the sign changes. That's a principle of math that we have to follow. The plus goes across the equal sign, makes it a minus, right? If we go up here, plus became a minus when it crosses the equal sign. So we're left with 2x equals to 8. So are we done? No, there's 2 x's. We need 1 x. right? So there's a little like term 2 in front of the x here. So to get by x by itself, I've got to think of the inverse operations we just talked about. We know that 2, when you don't see a symbol between a number, which is called a coefficient, and a letter, x, if you don't see an operation between them, you know it's times. It's assumed to be a times. So the inverse of times is divide. So we're going to divide by 2 on both sides. Why do we do that? Because to get x by itself, I cannot have any number but 1. I have to have 1 at the end. 1 times the letter x, right? 2 divided by 2 is 1. 1 times x is x, so I'm done, right? I have the variable by itself on the left side of the equation. So 2 divided by 2 is 1, right? I can cancel these out. 1 divided by 1 is 1. 1 times x on this side. 8 divided by 2 there is 4. 1 times x is x. So x is 4. Always box your answer at the end. That's a great way to finish up the answer. Let me see here on the screen if it looks hard to see. I can see it. It looks pretty good. Can you guys see all that stuff over here I wrote? Okay, maybe you can see the reflection of those lights kind of concern me, but I can kind of see it from here. When I'm back at the board, it looks blurry. But I'm getting old, that's why I wear glasses, right? All right, going back here. That's a good example. That was a 2-step single variable equation. I subtracted 7 and then I divided by 2. So that's a 2-stepper. Those are kind of fun. Here's a fun one. X divided by 3 minus 5 equals a -1. So here we have another 2-step single variable equation. How do I know it's an equation, not something else? There's an equal sign in it. Once you see that symbol, hey, it's an equation, okay? If there's not a symbol there, we call it an expression in math. Just to confuse you, right? Keep you moving. Equal sign, equation. So before we just stare at it, right? You kind of look at it, you kind of go, what's going on here? Well, we have an x, right? Variable. We've got a 3. Coefficient goes in front of the variable. A -5, good to know, it's a term, right? And there's an equal sign that separates it from the -5 to the -1. So there's another term, -1. These symbols is negative symbols or subtraction symbols, equals, and the negative, those are all separators. They separate, so we know where the terms are. So when I'm looking at it, I'm like, oh, there's one term here, right? X divided by 3. How do I know it's separated? Because there's a negative next to this one. -5 is a term, and there's an equal sign. Another separator. There's a -1. So I've got 1, 2, 3 terms in those circles. Now, do I need the circles? No. I just wanted to show you how I group numbers to know how many terms we have in this equation. We've got 3 terms, 1, 2, and 3. Why is that important to know? Because terms can be combined, like terms we call it, right? We're going to combine, you always hear that in math, we're going to combine like, not on like Facebook like or heart on your Instagram post, right? We're going to combine like terms because they're similar. I can put them in the same pile. They look the same. -5 and -1 look the same. Why not the 3 here yet? You know, as a coach, there's a 3 here. It's a number, but when it's attached to a letter by multiplication or division, like this one is, this one's a divide sign, see the little fraction symbol right here? That's a divide sign in math. That makes it attach, like glue. Can't separate it yet, but we will at the end. We want to combine the easy ones. These are easy. -5 and -1, right? But we can't just subtract those. There's an equal sign in between. And what do we learn about equal signs? When we cross them, you got to do the inverse operation. So this is a -5, right? Subtract 5, whatever you want to call it. minus becomes a plus when it crosses the equal sign. So I'm gonna put plus 5. If it doesn't cancel here, when I'm moving it over, you know you didn't do it right? One of the numbers should go away. And which way do we go? We're pushing the numbers, the like terms, away from the letter or the variable. So that cancels. And we're left with x divided by 3 equals 4. Are we done? No, we're not done yet. There's an x here. X has to be by itself. Is it by itself? No, it doesn't. You have to take that divided by 3 here and make the inverse operation to make that go over to the other side. So divide turns into times, right? So right here, I'm just going to put parentheses around it. That makes it times in math. You can just put a parenthesis in 3 and you don't have to write anything else. It makes it into multiplication. This is on the top of called the numerator, 3 over 1. That's why the 3 cancels with the one that's in the denominator below the x. Those cancel. So those become 3 divided by 3 is 1. 1 times x, and then you have 12. Do you have to show the step 1 times x? If you understand if these canceled, you're left with x, you don't have to show the 1 times x here. But I always like to show it just to make sure you understand when I cancel. 1 divided by 1 is 1, divided by 1 is 1, left with 1 times x. 1 times x is itself. That's the identity property of multiplication. Anything times 1 is itself. So you're left with x equals 12. Box that answer. Boom, boom, boom. Got the answer, got your boxing in, and we're done with that problem. Could I check my answer? Sure. If I wanted to take this x equals 12, pull it back to the original problem. I'll take that -5 off, or show that work out for this one. Came up, if I took the original number, put 12 back into the x, 12 divided by 3 is 4, minus 5. 4 minus 5 is -1. So this would check off as being correct answer. You can also take the answer and plug it back into the original equation and you can check your answers. All right, good job. Have any questions? Huh? Oh, that's right, you're not right here with me. But at the end of this presentation, you can, hopefully you're here in the classroom with me, we can talk about it. Also, you can also email me, that's the harder way. You can do on Google Classroom. And hopefully we'll have some video if we're not together. And with the video, you can video chat, right? Get all those nice splice, Zoom and Google Meet and all that stuff. So I'm sure we'll use them all over the year time frame. So answer your questions. If you have a question, you can't get it answered right now, don't be upset, because I'll give you time to answer. I'll make sure I can answer your question before you get all stressed, okay? So you'll be okay. I'm here to teach, I'm not here to punish you. So if we're here learning and you don't get what I presented because you're not here to ask me, hey, listen, just write down your question and I'll answer it later, okay? When we can get a hold of each other. Hopefully you're here in front of me though, so that's good. I'm recording this before the school year, just to get some lessons going for you guys, okay? All right, here's one with the distributive property. This is kind of a fun review. 3x minus 2. We have 18 on the right side of the equal sign. We got two parts, right? We got the left side of the equal sign and the right side of the equal sign. Kind of make scales. You hear math teachers talk about scales. There's a left side and a right side. If it's an equal equation, it has an equal in it, which means at the end we wanted to make sure that both sides would end up being equal. When we checked our last answer, we found out it was equal, didn't we? We took the 12, we divided by the 3, got 4, then we subtracted the 5, and got -1. Both sides were -1 at the end, right? That makes the scale equal. So we know that that answer is right for that problem. Well, this one here, we have 3 times the quantity of, that's what they always say with parentheses, the quantity of. Kind of groups them, those are grouping symbols, or parentheses. They say, hey, look at me, x minus 2, I'm right here. And this outside number says, hey, listen, I'll take 3 times all of you, right? outside number, say, I'm gonna distribute to both of you. Make you bigger. If it's a integer, we can make it smaller if you have a negative integer, or it could make it smaller if it were a fraction. Now I'm thinking through it all, right? But this is a positive number, so I'm gonna make these two bigger because a positive number, when you multiply it, makes it bigger, right? We know that. This is 3 times x, right? When you do distributive property, the outside number here, 3, is multiplied by the 2 terms on the inside, x and the negative 2. So I'm gonna take 3 times x, which is 3 times 1, right? 3 times 1 is 3, and then you have an x. Then you have 3 times a negative 2, which is a negative 6, equals 18. At this point, we have to look at our terms. How many terms do we have? We go back. Remember, if letters or numbers are separated by plus, minus, and equal signs, those are called terms. I see a minus and an equal sign. That means I've got 3x as a term, I've got negative 6 as a term, and I've got 18 as a term. 3 terms. 2 of them, I got to see if I got to combine like terms. Which ones are alike? 3x? There's an x in that one. Negative 6, that's an integer, right? Positive, negative. Integers there, negative 6, and then an 18, positive 18, right? So just a number without a negative in front of it, it's positive, we know that. I think the negative 6 and the 18 are the integer, or the like terms, right? So I'm going to move the negative 6 over to the 18. Why am I moving it to the right of the equal sign? Because I've got this 3x here on the left. Remember, letters left, as a general rule, numbers right, you get most of your problems right. That's a good way to remember it. Now, as you get along, if you go further in math, they'll put variables on both sides. And then you can choose which side to put it on. But man, I like to leave my letters to the left, if I can. But if they give it to me the opposite way, that's fine too. But right now, letters on the left, let's keep it on the left. So minus 6 and the 18 need to be combined. Look up here, what's my inverse operation? Minus becomes a plus. The negative 6 and positive 6, that's 0, right? That goes away. Left with 3x on the left side of the equation. On the right side, I'm going to add 18 and 6. 24. Last step. We have this 3 and this x. Those are attached by what magic symbol? If we don't have a plus or a minus between them, or a divide that we can see, those are the 3 we could see visually. If you don't see anything between them, it's assumed in math to be of times. So 3x doesn't have a plus in between the 3 and the x. It doesn't have a minus in between the 3x. And I don't see that division sign that we saw in the last problem. So I'm going to assume that's a times, which I know I'm right on this one. So I'm going to go inverse of times, times is divide. So I'm going to divide by 3 on both sides. Why don't I divide by 3? Because there's a 3 in front of the x. I just copy that number down. I'm going to divide because it started off as a time. I went over an equal sign. Again, it's the inverse operations. It's the same rules every time in math. So 3 divided by 3 is 1. There's my big 1. 1 times x there. 24 divided by 3 is 8. 1 times x is x. X equals 8. We box it. Box that answer. Boom, we're done. X is equal to 8. So I think I'm going to give you some problems to do on single variable equations, similar to these. Some that are 1 step, these are 2 steps because it took 2 steps to get down there. Had to add the 6 and divide the 3 at the end. That's a 2-stepper. The first problem we did, we wanted to do 1 step because that's all I needed. So if you have any questions, let me know. Be happy to help you on the assignment, but look in your Google Classroom for the assignment on single variable equations. This will be a great review for us starting the year. Good luck, guys. You can do it.